All right, so with 6.4, we are modeling with quadratic functions. So we're doing lots of word problems today. That's what that means.
Word and function problems. Love it.
Yeah. Yes. Okay, so our objectives are to write quadratic functions modeling real-life applications and use them to solve problems and determine the equation of a parabola when we're given the points on the parabola. Okay. All right, so example 1. Let's get all our workspace here as possible. All right, Philip plans to construct a dog pen off the back of his garage using its back wall as one side of the pen. So we've had a problem like this before. A couple actually, and constructing the rest of the rectangular pen from 28 feet of fencing. Determine the maximum area of the pen and its corresponding dimensions. So our first things here, because our setup is a little bit different, I've started typing up our notes in hopes of that being a little quicker. So the first kind of thing to help us out is to draw a picture. These are kind of the hints to kind of walk us through the problems. So let's draw a picture. He's going to use the back wall as one side of the pen. So I'm just going to draw a line and label it as wall. Okay. And we want a rectangular pen, right? So I'm going to... We don't know. We don't know. This is true. That is the problem. So then we do need to label it, though. We need to label the side lengths. And so if we find out that it's wrong, then we should be able to label it where it's not wrong. But when we get it, it might be that this is actually the short side and these are the long sides. We don't know. If I was building a fence, I was like, if I was building a fence, I would get the maximum, because I do want the maximum area that I would use this wall as the long side, technically. But, so how would we label this? Because the next step is to write a function modeling it, but I need some labels here.
Wait a minute. It's not saying that
There's nothing that tells us how to label it, though.
There's only
the word wall, but that's it.
There's one more piece of information. The 28 feet. We have 28 feet of fencing. That's huge. So we know that this is our fence, and that fence has to be 28 feet. So how would we label it?
Put 28 somewhere on there.
28 is the whole thing, though. So that wouldn't help me.
So you have to break 28 into 3 different pieces.
What size pieces? Well, but we do know it's a rectangle, so we can't use any size pieces that we want.
2 equal pieces and 1 long piece.
Ooh, 2 equal pieces and 1 long piece. Okay, I like it. So,
x squared plus x.
all right, well, I'm not going to put x squared in there for my long pieces because it's a length, right? It's not an area. Squared would imply that it's an area.
Like you could say if you're trying to find.
Okay. So if those two sides are x, what would the length be then?
X times 2.
I don't know.
The length wouldn't be x times 2.
Y.
But then you have 2 variables. If you have 2 variables, then you add a whole other, that becomes into a system to solve it.
Oh, no, it'd be 28 minus 2x.
Okay, I was saying, so you have 28 feet, and you took out an x, and you took out another x.
X squared.
So this, nope. Negative x minus x is minus 2x. Only when we multiply x's do we square them. X times x would be x squared. So this side would be 28 minus the 2x feet. That way we've kept the same variable. Okay, so we don't have to work in the with like a system, and we have accounted for the whole 28 feet and taking away the 2 x's for each side. Okay, all right, so let me erase this. So our next step then was that write a function modeling the area of the rectangle. So what's the area formula for an area? Length times width. Okay, so the area of a rectangle equals length times width. So in this case, our length is 28 minus 2x, and our width is x. All right, so let's simplify that because we need to distribute, right? Well, because it's 28 minus 2x times x. Yep, so we'd have 28x minus 2x squared. So that's our next step there. So this is where it might get a little hazy. Wait, why does it end up being what? Because we had to distribute the x. X is the width.
Because area's length times width.
Okay, so yeah, because we did our length. Okay, so you see it? Okay. All right, so then it says, since the vertex is a maximum point, find its coordinates h and k.
How do we know if it's a maximum?
You're not reading the right thing. Wait, what?
The next little hint
How
here.
in the world is that? But that's only with parabola stuff, right?
Well, isn't this a parabola? Going to be a parabola?
No, it's a fence.
It is a fence, but since we have this x squared value, it's a quadratic, and a quadratic is parabola. Remember yesterday we said it should be called a quadrabola instead, because a linear equation makes a line, a quadratic makes a parabola. How do we know it's a maximum point?
Because it says the maximum area?
Because it says the maximum area. Yes, we want the maximum area. I know, right? This is what, like I said, we're just working on this today. Because they are kind of.
I guess we can do it. I just find it really weird.
Mm-hmm. It is kind of weird, but so it's like we're just gonna check it out and see. Like I'm not disagreeing that it's weird, especially the first time you see it. So it's like, well, okay, I've got this formula. How is this gonna help me? So we'll look through it. So does anybody remember the formula to find h?
It's like a and then times the quantity x minus h plus k.
Nope, that's a little harder. It's b, or it's negative, pardon me, b divided by 2a.
What?
The formula to find our h in the vertex is negative b divided by 2a. So we're going to pull those right from here. The only problem is our area currently isn't in the right order.
No, it should be negative 2x squared minus.
Right, because they should always be in descending order. So we should change this to be a equals negative 2x squared plus 28x. So we're actually going to pull it from this form. So our h is going to be negative. What's our b value here? It is the same thing, but we've changed the order because remember it's ax squared plus bx equals c is our standard form. Oh, sorry, equals c is our standard form.
So it's still not standard form.
Because the a is over here. You mean like, yeah, the equal can be on any side. It could be c equals ax squared plus bx. That's fine too. But we want the, like, or in, here's the thing. You don't have to have it in standard form if you remember that your a value always goes with the squared term. Your b value always goes with the single variable as well. So that's just kind of personal preference. Doesn't have to be. But in order to pull it, like to fill this formula, we want the b value. So is the b value negative 2 or is it 28?
Negative 2 or 28, sorry.
Okay. It's the 28 because b is with the single x variable. So we're going to have, let me change colors back here so we can see a little better. So it equals 28 divided by 2, and what's my a value?
Wouldn't it be negative?
Mhm.
Never mind.
No, it's not just a. Okay, a is our c value. They chose the variable a to, like we're using the variable a for area, but that is our C value because it's the one that's a constant. That can be very misleading.
It might be helpful if you change the A on the formula that you wrote down to lowercase.
Up here?
Yeah, so that way the...
Okay, we can do that. Okay, so you want ax squared plus bx equals c, or we could have c equals ax squared plus bx. That's fine with me. Mm-hmm. Okay, so our a value is -2. So then we're going to have -28 divided by -4. Negative divided by negative is a positive. What's 28 divided by 4? So our h is 7. So let's try the k value.
I don't ever remember learning how to find the h. I don't remember seeing that formula with the negative b divided by 2. I don't remember using
I'm trying to think. And it may be one that we went over quickly or skipped over. Yeah.
What's the k then? What's the formula for k?
Well, and so here's the thing with this one. Like, if we have the h value, then I don't know necessarily like the book says we have to find the k value, but do we have to find the k value, or can we like kind of start to? Hmm?
What is the K value?
What is the k value?
Like, what's the equivalent of it? I think he's saying not like what the actual
Like,
number
I don't
is,
know
but
if
like,
I need to find K or not if I don't know, like, I don't know how to explain this.
I see what he's saying though, because he's like, okay, so I don't even know if I know how to explain it either.
Like, I don't know if I need to find it if I don't know if not
Like
finding it is gonna help or not.
If you don't know if
Like,
not finding it is going to help or not.
Like he doesn't know what k stands for. Like
yeah.
what k
Like, is K a wall? Is K the amount of fencing? Or is K like how many people we have?
Okay,
'Cause
good question.
if it's how many people we have, then we don't need to solve for K when we're trying to figure out the wall. But if the K has something to do with the wall, we need to find it, I assume.
Yes, good. All right, so we're saying, it says, since the vertex is a maximum point, find its coordinates, h and k. So how do h and k and the vertex, how do those connect? What is the connection between h and k? Tune back in to me, Brandon. I can tell you're zoning out. Tune back in. What's the connection between the vertex and the h and k?
H and k make a vertex in like an ordered pair.
Okay, h and k are the ordered pair of the vertex. Okay, so it's h comma k, right? Well, what's an ordered pair in a linear equation? What are the variables that we use for an ordered pair in a linear equation?
X, Y.
X, Y. Okay. They're actually the exact same. H is equivalent to X. So when you solve for your H, that's a number that you can plug in for X. Because H and X are equivalent. And so because we have function notation, instead of just writing it as A, the area, we could say, well, the function of X equals -2x squared plus 28x. So it doesn't matter if I'm using the letter A for area or the letter F of X. What do those represent in an ordered pair? What value? The Y. Okay, in a quadratic, in the vertex, what does the y represent? The k. So when we solve for h, we actually solve for the x value. In order to solve for the y, we need to plug that h or x value. So I'm going to write here x equals 7 as well.
Why don't we just write it as that? Why do we have to use h and k when it's the same thing?
Because we already have an x in the variable. Like in the formula, we already have an x in the formula. So if we said x, it would be more confusing to have more x's. Okay, and then when we use vertex notation, we have an x and a y and an h and a k. We have all kinds of different things. So there is overlap. And we're solving, but like when we do it, we're solving for x, we're getting our zeros and different things. So because there are more pieces to the puzzle, we have to start naming them a little bit differently. But if you can take it back and be like, okay, h is the same thing as my x value, k is the same thing as my y value, then you're okay.
To solve for y, you just take the zeros, but that's not right.
Okay, so we're going to do f of 7. We're going to plug it in.
Okay, I was gonna say, do we
Uh-huh. Yep, equals negative 2 times 7 squared plus 28 times 7. So this is going to equal negative 2 times what?
49?
And what's 28 times 7?
196.
Okay. So negative 2 times 49?
That is 98.
Negative 98 plus 196.
So it's gonna be a positive 98.
Okay, so our f of 7 equals 98, but our f of 7 is also our k. So what does this tell you?
Where our vertex is? But like, how does vertex help us? Because that's not what I'm trying to figure out.
Okay. That's impressive. It's making the screen. The work downstairs is making the screen shake.
What are they trying to do anyway?
Downstairs?
Yeah.
Oh, I have no idea.
Oh, okay.
I just know that they're
Working.
working. Obviously.
So are we gonna try and use the parabola to graph stuff, or like, what's the use of the parabola? The coordinates and vertexes.
Okay. And so that's the thing. We're trying to figure out how quadratics relate to this. Okay.
So we're gonna like at any point draw like a graph.
Nope.
Thing? No,
Nope.
just
We're not gonna graph anything.
Okay, so it is our y, but like that's all still with like graphs, nothing to do with this. We know our k, our x. Is our x there the same as the x up there?
X, why can't we just plug
X
that into the
like is that's what I was gonna ask. Like is the x
Oh, why
equals
can't we just
7?
plug that into the wall?
Yeah, so if x
Yeah.
equals 7, can we plug it up there?
Why can't we?
I don't know.
So 28 minus 2 times 7 would be 28 minus 14, which would give us 14.
And there's just 7 on each
So
side.
what are we trying to find?
And so it's 7 on each side. We're trying to find the length of the walls.
So it's gonna be 20.
Really, it doesn't.
We didn't define
You could
k
get a couple
then.
different answers then.
Okay, what was that, Brandon? You're both talking at the
You
same time.
could get a couple different answers then.
To find the length of the walls?
Depending on what side you put the wall on, like the actual wall of the house, or whatever it is. Depending on what side.
Okay. So when we did that previously, we got a couple different answers, like, because we got the right numbers, we just had them on the wrong, like labeled on the wrong walls.
So then we have our answers. Now
Uh-huh. Okay. So,
So is that not the right answer?
no, that is the right answer.
Well,
But it says
calculate
determine the maximum area of the pin,
which is 98, which is what our K value is.
which is what our K value is. Okay. So,
How'd you? What do you mean maximum area?
I'm so confused.
That's the area inside.
Yeah,
yeah, the area, so the area inside. So if we calculated the area in here,
It's gonna be 98 square feet.
how'd you get that?
by 7 times 14, the
Okay.
length times the width.
So area equals length times width, since we know it. So that's the same thing as 7 times 14. And what is 7 times 14?
98.
So our area equals 98 feet. So how did our H and our K play into this?
The H was our X and the K is what we're trying to like find as our area.
We didn't really need to even find K. Once we had our H,
Well, I mean, K was the area.
Okay.
We wouldn't have had to find K, but it was the area, so it depends on how you want to do it.
So we wouldn't have had to find K, right? Like we could have once we found the H, we had our side length. We would have eventually had to find the area, but we wouldn't have had to go through it the way that we did it to find K. Okay, but now,
just doing length, once you have H, just doing length times width is much easier than what we solved as K.
okay, so this is true, but again, so like we're trying to get some perspective on how parabolas can like fit in and what the things mean as well. So we want to interpret a little bit, like, so we discovered that the H was our X value and the K is our Y value. So the X value told us what about our,
What's the width?
told us the width of our fence. Okay.
It told us length, width, and basically area.
It did not though. The X is only one dimension.
Yeah,
Like it
but
helped get us to all the others, but what part of it is the X?
The width.
Told us the width. That's what we labeled it as, right? We were able to use it for all the other things. What does the K tell us?
The area.
The area. So if we were graphing, like if we talked about, I said we weren't going to graph a parabola, and we don't have to. But we want to see that the X value, like this would be a graph that we'd be graphing the X-axis would be the width of the rectangle, and the Y-axis would be the area, like finding those corresponding relationships. Okay. So we're just kind of going through and playing these out instead of just looking at the problems themselves. How do we apply this to an actual word problem? How would we do that? Okay, so let's try example 2. All right. A flight between two cities averages 81 passengers when the airline charges $210. The airline estimates that it will lose one passenger for every $3 fare increase. What is the maximum revenue generated by this flight? And how much should the airline charge to achieve this revenue?
Why are we losing passengers?
Because they're increasing the fare.
Yeah.
They're making it more expensive.
Increasing the
And so people are like,
That
oh,
kind of loss. I'm like, you're not supposed to want to. Never mind.
okay. So that's right. But that's the thing is like these word problems are not the easiest to solve. Now, the other thing is, would I attempt to solve this necessarily as a quadratic naturally? No, we're trying to stretch ourselves a little bit here, right? To persevere and stretch ourselves to see if we can use a quadratic to help us. Okay? Did you say no?
No.
Okay. Because again, it's not the only way to solve it. It's definitely not the way that I would naturally start to solve it by any means. But that's our goal here is like let's stretch ourselves some. All right, so what's the important information in the word problems?
Number of passengers, the original.
Everything?
Okay.
The number of passengers, the
80,
original price.
okay, $210.
$3 increase for every one passenger.
Okay, so we need to get they lose one passenger for every $3 fare increase. Okay.
And then the main question at the end is the main key unknown. That would be like our X value.
Okay. So our main, let's what is the maximum revenue generated by this flight?
And then it's also asking how much do they earn.
What's the revenue?
Okay, so how much should they charge? Okay.
So you're gonna have to divide 81 by.
I don't.
Yeah, divide because for every $3 you go up, you're gonna lose a passenger. With 81, the maximum would be having one passenger paying the thousands of dollars for that plane ticket. So to find the maximum,
Flight.
you're just gonna have to take.
Wait. I don't understand what we're trying to find. Are we trying to find how much money we can charge, or are we
It's
trying
how
to
much-
find how many passengers we can have? I don't.
So okay. So
Revenue
it's
is
saying-
money.
Yeah. So it's saying how much money we should charge each passenger to get the most amount of money we can for each flight. So we might have less people but have them pay more, or we might have them more people but paying less. Like we're trying to figure out what is the best like percentage, right? Like the best, like the most amount of money we can get out of how many passengers we have, like for each passenger.
It's gonna be. You're just gonna have to increase the $3 until you get one person. It's gonna be.
Yeah.
That's not necessarily the best
If
way
you're
though.
trying to get the maximum amount of money, you can just.
Not for every person though, it's the amount of money total.
Yeah.
Yeah, you can just.
Because the
keep
more people you
putting
add,
3.
there's only a maximum. Because you only have 81 people that are paying $210 each. But
And then
if
if
you
you
increase your
it-
price $3, you lose a person, but your price is still going up.
price is going up, but it's not saying per ticket. It's saying as a combined total. So if you have
Okay.
81
So I
people,
think you're saying the same things, just in different ways.
maybe.
I have no idea.
So
Do you
let's
think
take
it's
it.
just best to just increase it by 3 for each one to get one person paying a very high price?
Yes.
Right.
Because that's the
That's-
best way to get this.
So that's the most amount of money you can charge.
No.
Okay, so let's look at what happens here. So currently we have 81 passengers. We're charging $210. How much is that?
A lot.
$210.
A lot is not going to cut it. Get a calculator, do some math. What is 81 times 210?
Oh, that's what you're.
Yeah, like I want an
I thought you
actual.
were asking how much is $210. I was like.
No.
200.
We have how much? Like what is the revenue? Like this is how we calculate the revenue. How many?
$17,010.
$17,010. Okay, can anybody confirm that?
Sure.
Sure doesn't count either. Like I'm a mathematician. I want accuracy, not sure.
Yeah.
Yes.
I got the same thing.
Okay. So I mean, like we can, because that's the thing is to understand the problem. Sometimes we have to think through what it's saying. So then it says that we lose one passenger for every $3 fare increase. So if we drop to 80 passengers, what's the fare at this point increase, or what's the fare cost?
213.
$213. Okay. So what's the revenue that's coming in?
$17,040.
So this is what we're talking about. Like, wait a minute, we lost a passenger, but we're making more money. Okay, so if we go down to 79, what's my fare increase? 216. Okay, so what's my revenue? 17,064.
No, I got
I got
954. How much is it?
Oh.
126. I did one. Yeah.
Okay, so what is it?
$17,064.
Okay. Okay. So do we understand what's happening? At some point, what is going to happen?
You're gonna have one passenger paying a very big amount of money, and it's gonna be the most amount of money that you can make.
No, it's actually gonna start going down.
So do you think it's going to be one passenger? Or it's going to be multiple passengers?
It's gonna be multiple. Because there's gonna be a certain point when you keep increasing the price that there's gonna be so few people, you're still not gonna be making as much money. That's what I was trying to say earlier.
Okay. So
if you do one, can we just do that? Like 1 times however much money it would be.
how much money would it be though?
still need that one passenger left at the end. So 80 times 3 equals so 240. So you do 240 times 210. Would that be it?
Should be.
Yeah. So 240 times 210 equals 50,400.
No, I say it shouldn't be times 210 because it was only a $3 increase. Let's see.
Plus 210. So 240 plus 210.
Yeah, it should be 240 plus 210.
So 450.
So 450.
Yeah. Just to see if you have.
So if we have one person and the fare is $450, they're only paying $450. That's the revenue that the airline is getting is $450. They don't want it to get to that place. But there is, so here's the thing. This is where it models this parabola. Okay? So if we think about the number of passengers, right, and then the cost. All right? So at some point, the number of passengers is like we're starting over here at 81, and the cost is, we'll say down here at 210. Is what I should have. Okay, and so here's 81. So the number of passengers is decreasing, but the revenue, it's not this low. My graph is not very good. I'm going to start my graph up here. Okay, so 81 passengers at $210. So the passengers goes down, but the cost is increasing. Okay, and the cost continues to increase, and then our number of passengers is decreasing. At some point, we're going to hit a max, and then the passengers are going to start coming down with our parabola until we eventually get to 0. That's what we're looking for. Okay, because this is an indirect as well, like it's kind of an indirect relationship at this point, because as one of these, like our passenger number is decreasing, our cost is increasing. Okay, the passenger number decreases, our cost is increasing. At some point, it goes the other way, and they both, like it becomes, we get the other side of the parabola. So we're looking for this point up here. When does that happen? And you can keep solving this all the way down until you find where it happens. That's one way to solve it. We're trying to stretch ourselves today to use a quadratic to solve it. This strategy would be effective. It's going to be time consuming, but so is like solving a quadratic. But the quadratic is new, it's challenging, it's difficult, it's uncomfortable, it's all those things. So that's what we're trying to work through the discomfort to get there. Are there questions about this graph before I erase it? Because I don't want to keep it. Okay. Okay. So the first thing then is to assign a variable to the key unknown. So what do you think is our unknown? Ooh, how much money is our unknown? But that's what we're trying to solve for. So it's, well, yeah, but what else is I mean, like, that's what we're solving for, though. Like, we know what revenue is. We have what we need to get it.
Is that not what the unknown is? What is the key unknown then?
How much the airline should charge for each person.
That's what
Okay.
we're trying to find, though.
Yeah, it's the same thing.
Yeah. We're trying.
But they're
well,
not the
actually,
same.
we're
Time
trying
out. Time out. Those are not the same thing. Let's clear this up. Revenue is the amount that we get from the number of passengers times the fare that they pay equals the revenue. That's what we just started. So this is the number of passengers. This is the fare. This is the revenue. Okay? So these are different things. So when we're looking for the key unknown, what's the thing that everything else hinges on?
The revenue. The fare.
passengers. I don't know. It could hinge on some. We have 3 things, and it could hinge on all 3.
Okay? But ultimately, so think back through it. The revenue, where do we get the revenue from?
Money and passengers.
The money and so the number of passengers and the cost. Okay. Or the fare. Okay, good. Where does the fare come from? They want to change the amount of fare to get to the maximum revenue. So they're going to change the fare until they can get to their maximum. So what does the fare hinge on? The passengers. So what's our ultimate? That's the number of passengers. Okay, because everything else is altered because of the number of passengers.
So per se, if we
It would just be different, yeah.
Wait, then
Because it's still
the
multiplication.
fare depends on the number of passengers, but the number of passengers also depends on the fare.
True.
I don't know if it depends.
So how is...
So you could solve either one.
Yeah.
I mean, you could, yeah. Like that's the thing. Like the book says the key unknown. I don't agree necessarily that it is the key unknown, but I'm just saying, like, if we also look at it from like what you said, like the fare also depends on the number, or the passengers depends on the number of fare, but what is kind of ultimately out of the airline's control here? Like they can control.
They can't control how many people are on their plane.
Right, they really can't control how many people are on their plane. They're looking at the average. So they're trying to take the thing that they can't control and figure out the best way to control it the best that they can. Okay, so when we give a variable, our variable is going to be the number of. Do we want the number of passengers? Is that? Hold on. I was like, it's Ian. My goodness. Do we think it's the number of passengers now?
I don't know.
And also at the very end, it's asking how much they should charge.
So you're gonna end up finding them both, no matter what you do, because you're gonna indirectly find one when you're trying to find the other.
Yeah. Because we also have to find the revenue generated, so we'd have to find the other two to get the revenue.
So you're trying to find all three. It's just a matter of which one you do first.
So we label them K and H.
Okay, so hold on. Like you guys are getting the cart ahead of the horse. Like we can't solve the problem until we actually know, like, kind of get our unknown here. So I don't think that we're settled on this number of passengers or the fare thing. Is there something else we're missing? It's okay to be frustrated. Just don't shut down on me.
Amount of revenue.
Don't know how much money you're gonna make in the end.
You don't know how much money you're going to make in the end?
You don't know where the peak is, so you don't know how much money you can get.
Wait a minute. Are we trying to find the vertex? Is that like
That would be
the max?
that'd be the same.
That'd be the maximum revenue generated.
Yeah.
Mm-hmm. Because then we could have, depending on what it is, well, I'll stop there. So where do we want to put our variable? Like what is our x going to be?
Is there like a wrong answer to it, or is it just what we want to do? Because could we say it's either one of those, or is there like a right one between those two?
Why don't... Since we have passengers, fare, and revenue, why don't, instead of trying to use X and Y and all that stuff, why don't we just use P, F, and R? P
Because then
times
you don't
F
have any
equals
numbers
R.
in your equation. Yeah, you would, because it gives you values, so you could do that.
Okay.
I don't know what I'm doing. I'm throwing out crap and seeing what sticks.
Okay, so let's take it to a different place. If we were looking at this as a linear relationship, okay, then, or like looking at the right of function, what could you write about this? Like, how are these things related?
Your number of passengers, or your number of passengers is regulated by your fare, and your revenue is also regulated by the amount of fares.
Okay, so how would we write an equation, for a function for that?
P times
Number
F
of
equals R.
Like let's go with this. What's my price per passenger?
Currently?
No.
Oh,
What's my price per passenger? No matter what. How can I calculate my price per passenger?
fair.
Fares
Passengers.
Okay, but what's my fare? It's changing the whole time.
revenue divided by your amount of passengers.
But I can't get my revenue unless I know the fare and I know the number of passengers.
So you can't solve this because you don't have.
We can solve it. It's a matter of figuring out what our variable is. And so I'm trying to look at that question from a different perspective because we need a variable that we can plug in here. However, that was the bell, so I'm going to let you go. But I want you to just look at this example tonight or this weekend. Go over example 2 and see if you can like figure out, like write me a function for the price per passenger and a function for the number of passengers. Okay, so give me functions for 2 of these. See if you can come up with a function. Now, when I say function, right, like I'm talking about if we paid $10 per CD, okay, then it would be 10C, right, would be my expression. So write me see if you can figure out a function, because if you can figure out a function, then you can figure out your variable. So just do that for tonight's homework.